Hello, this is John from TC Math Academy, and in this particular video, we're going to practice simplifying rational expressions, and specifically, we're going to be working on this problem right here. So 15c squared minus 23c plus 4, all that over 10c squared plus 3c minus 1. This is a rational expression, and we want to simplify it. So if you're not quite sure what that means, I'm going to fully explain this here in a second. But in order to do this problem, you need to have pretty serious factoring skills, okay? Now, all students, all algebra students, that is, should have excellent factoring skills because it's probably the number one skill that you need in order to do algebra, okay? You have to be great at factoring. And here we're dealing with two trinomials. I'll just state right off the bat that you can factor these trinomials, okay? But how you go about doing this, again, could be challenging for a lot of you out there. But if you can figure this out, go ahead and put your answer into the comment section. I'm going to show you the correct answer here in just 1 second. And then we're going to go through how to simplify rational expressions. And we're going to do a quick review of factoring trinomials, right? This is going to be really important for those of you out there that are taking some sort of math class that involves algebra. Also, if you need math help with the course you're taking, test prep, or homeschooling, make sure to check out my math help program at tcmathacademy.com. You can find a link to that in the description below, and if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let's go ahead and take a look at the answer. So we want to simplify this rational expression. If you did this correctly, you would have come up with the following. So you would have gotten 3c minus 4 over 2c plus 1. That is the answer. Okay, so how'd you do? Well, hopefully you got this right. If that's the case, that's very good. As a matter of fact, I'm going to give you an A plus, a 100%, and multiple stars so you can tell your friends and family that indeed you know how to factor and simplify rational expressions. Now, factoring is a big part. Well, it is the number one skill that you need in order to solve this problem. So let's just quickly talk about factoring in algebra. Okay, now I'm not going to teach you everything here because this is a big topic, all right? This topic here covers, spans more than a few chapters in algebra. Well, let me see here, at least a couple, 2 or 3. It's continuously used. So the first thing about factoring that you need to be able to do is factor out the greatest common factor, right? So if you have something like 2x plus 10, you got to be like, oh, I can factor out a 2, so that's 2 times x plus 5. 2 is the GCF. So these type of problems here, which are effectively you're kind of using the distributive property in reverse, is the GCF. So you got to be a pro, professionally, trained, if you will, at the GCF. And you might be kind of laughing at me like, man, this guy, he's over the top, this math guy, talking about being professional. Listen, you need to have an attitude of excellence if you truly want to be good at math. Okay, if your attitude is like, yeah, I'll know a little bit here, a little bit there, that's not going to get you where you need to go, right? Math is a language. You want to get as good at all the different aspects at it, all right? That's how you get great at mathematics. All right, so the first thing is the GCF. Then the second thing is you're going to move on to the topic of trinomials, right? So things like what we're dealing with, 2x squared plus 7x plus 1. These are quadratic trinomials, and there's two types. I'm not going to get into them here. There's what we call case 1 and case 2. Case 2 is, well, let me just tell you what case 1 is. So case 1 would be something like this, where the leading coefficient, the number right here in front of your squared, could be x squared, y squared, doesn't make a difference. If it's 1, it's what we call a case 1. Not all textbooks are going to refer to it as a case 1, but I refer to it as case 1. So you got to learn how to do these problems. And then if you have anything other than a 1, like here, I'll just put a 7 right there. This is a case 2, but you got to be able to factor quadratic trinomials, and that's what we're dealing with here in this problem. Then the next thing is you're going to have to know all your special factoring rules, things like the difference of 2 squared, on and on and on. There's a lot of different special factoring rules. Got to know that stuff. And then last but not least, you got to learn a little bit more advanced factoring techniques, which would include like group factoring, etc. We're actually going to be using a little bit of that in this particular problem. Okay, so just in general, this is the stuff that you need to know about factoring in algebra. Okay, so I'm going to leave links to my algebra courses, namely Algebra 1, Algebra 2 in the description below, so you can improve on whatever you need to improve on, right? Don't just kind of do a little tutorial here, a little bit there. You want to master factoring. It is critical to be successful in algebra. Okay, so we're talking about rational expressions, and you need to understand this word rational. Okay, so here is a rational expression, right? Now, I have an equal sign here. We're just trying to simplify it, but this would be an expression. And anytime you're thinking about or you hear the word or see the word rational in mathematics, you want to be thinking fractions. Okay, so a rational expression is basically a fraction where you have the numerator and denominator as some sort of polynomials, okay, or functions and whatnot. Now, there's some technical things about rational expressions, but basically, if you see a fraction where there's variables in the numerator and denominator, you're not going to call that a fraction. You'll likely call it a rational expression. Okay, so let's go ahead and review rational numbers. So here we're going to be simplifying a rational expression. That's the objective of this problem. But let's talk about simplifying rational numbers, okay? So a rational number is a number that can be expressed as a fraction, all right? So, a fraction like 24 over 60 is a rational number. It's a number that can be expressed as a fraction such that the numerator and denominator are integers, okay? So like nice, lovely whole numbers, things like this, 24 over 60. They can even be a negative 24 over 60, but this is an example of a rational number or a fraction. Now, we want to simplify it, but what does that mean? It means to reduce the fraction. So if you're like, oh, I got 24 over 60, can I reduce that fraction? Well, you want to always simplify values in mathematics, and it's not like an optional thing. Your teacher, really does want you to, learn how to do this. But the name of the game is factoring. So let's take 24 here and think of factors of 24. So I'm just thinking of 2 here. 6 times 4 is 24, and then 60. I'm like, okay, what numbers, are factors of 60? Remember, factors are numbers that you multiply them together. The product of those numbers gets back to the original number, right? So 6 and 10 are factors of 60, and 6 and 4 are factors of 24. So here, okay, what we're looking to do, and this is the same thing that we're going to be using to simplify this rational expression, is we want to identify like factors amongst the numerator and denominator. Okay, so here we can see we have a 6 here in the numerator and a 6 here in the denominator. These are factors, okay? Not addition, not sum, things that are separated by multiplication. But if you have the same factors in the numerator and denominator, you could cross cancel them, all right? So this is the idea is to factor your respective numerators and denominators, look for their factors, and try to identify like factors and cross cancel them. Okay, so when I cross cancel these 6's, I'm left with the fraction 4 over 10. But guess what? We can factor further, right? So factors of 4 is 2 times 2, and factors of 10 would be 2 times 5. You're like, oh, I got 2 here. These are like factors. It's 1 for 1. This 2 cannot cross cancel this 2 and this 2. It's just 1, 2 for 1, 2. So in order for this 2 to go away, I would need another 2 down here in the denominator. So what remains? Well, after everything is cross canceled, the last numbers that remain is 2/5. And so this is 24 over 60 simplified. That rational number 65 is 24 over 60. That rational number simplified, let me say that one more time, is the fraction 2/5. Okay, these are mathematically equivalent, right? It's the same value. We're just writing it in a simpler way. Okay, so we are talking about algebra here, but to truly understand algebra, you need to have mastered arithmetic and fractions, right? It's all continuous. Math is one big, lovely journey. Okay, so here is our rational expression. We want to simplify it, right? So you're thinking to yourself, okay, I'm just thinking about the same thing with fractions. My objective here is to factor the numerator and factor the denominator and try to find like factors. Now, there's no guarantees that you're going to have, uh, like factors between the numerator and denominator. So you don't know, how this is going to turn out, when you are given a problem. Don't assume every problem can be simplified. That's number one. Number two, you don't even know whether these trinomials can be factored. So in other words, if I give you a number like 20, oh, I can factor 20. That's 2 times 10, 4 times 5, no problem. But if I give you 19, that is a prime number. In other words, the only factor is 1 in the number, 1 times 19. Same thing with trinomials. Okay, there's no guarantee that you can factor these trinomials. But of course, we want to try, we need to attempt to do so. So we're going to go ahead and start by factoring this quadratic trinomial right here. Now, this is a good point in the problem for you to test your own skills. Maybe pause the video and see if you can factor this, okay? Because if you cannot, I would call this a 911 algebra emergency, okay? You have to know how to factor to be successful in algebra. But let's go ahead and get into this right now. This is a whole discussion in and of itself, how to factor case-2 quadratic trinomials, something like this. But a lot of you are going to be saying to yourself, all right, well, I have a trinomial. It's going to factor into two binomials, two things like this, okay? And I'm looking at this 15c squared, and you're looking at different factors of 15c squared. They're going to go in these positions right here. So 15c squared, I'm thinking, oh, that could be 3c and 5c, because those multiplied together gets me back to 15c squared, or it could be a 5c and a 3c in this position, or it could be a 15c and 1c here, or 1c here and a 15c there. And these are the first positions of these respective binomials. Then here I have 4. The factors of 4 are going to go in these positions, okay, right here. And now I have to try to figure out what combination of all of these, plus I have to do the signs, such that when I multiply these together, I'm going to get back to this quadratic trinomial. And this is where a lot of students get, confused. They're like, I don't like the factor. This is just way too much thinking for my brain. I'll just go and find myself a nice AI tool and plug it in, and it will tell me the answer. Yes, indeed, you probably could find a lovely algebra calculator or AI tool, but guess what? That's not going to help you out on your test, all right? Don't go for artificial intelligence when you yourself have the real intelligence. You just need to know how to approach these problems. Okay, so now what I'm talking about here is a method that you need to know. Okay, so this is the method that you can use, and this is oftentimes referred to as the guess and check method to factor quadratic trinomials. That's perfectly fine. As long as you can factor, that's what counts. But I'm going to show you a technique here real quick that will help those of you out there that are just confused with factoring, okay? Factoring quadratic trinomials. So here's a quick little take on it. If you really want to learn this with me, you got to get into one of my algebra courses, to get the full instruction and practice all of this. But I'm going to show you very quickly how it goes. So the first thing is your quadratic trinomial needs to be in standard form, highest to lowest power. So we have c squared, c, and 4. Now what you're going to do, you're going to take your leading coefficient, this number, and multiply it by the last number, okay? And we need to be aware of the signs. So 15 times 4, that's positive 15 times a positive 4 is what? Positive 60, okay? So now what you're going to do is you're going to start listing the factors of 60. Now, this is seems like a lot of work, but you don't have to kind of guess and check here. You just follow this procedure, and when you get good at this little technique, you don't even have to write out all the factors. Okay, you'll be able to just kind of see the answers. But factors of 60 is going to be, you're always going to write pairs. Okay, and I'm going to suggest you start with 1. So 1 times 60 is positive 60, right? These are positive numbers. And negative 1 times negative 60 is a positive 60. right? So now we're just going to go and continue this here. 2 and 30, that's, remember, multiplying here together. Positive 60, negative 2 times negative 30, positive 60. So we're just writing these factors, and I'm thinking, okay, what's the next factors? And what I'm going to suggest is this first column, just put your lowest factors that you can kind of think of, 1, 2, 3. If there's no 3, then keep going until you exhaust all your kind of pairs of factors here. But now we have 3 times 20 is positive 60, and negative 3 times negative 20 is also positive 60. But here is where we want to be, paying attention. Now, what am I doing? Okay, well, what I'm doing here is looking at the sums of all these factors. And I don't have to write them all out. So when I add these up, what do I get? The sum of these factors is positive 61. Here's a negative 61. This is a positive 32, and so forth. I'm looking for the pairs of factors that add up to this number here. Okay. Now, if you cannot find any pairs of factor that adds up to this middle coefficient, then this thing cannot be factored, right? But in this case, we have negative 23. I'm looking for negative 23 here. So I'm going through my list. I'm like, oh, negative 3 and negative 20. That's a negative 23. Awesome. So what does that tell me? It tells me I want to use these two numbers to help me factor this. Now, I'm explaining this, and this is a bigger problem, and you might be saying, this is a lot of work. But listen, you don't have to guess. You just kind of run this little procedure and you'll get the answer every single time. Okay, so what do we need to do with negative 3 and negative 20? Well, what we're going to do is rewrite this problem, okay, this negative 23, as the sum of these two numbers. So, and it doesn't make a difference if you write it this way. Well, let me just show you right here. 15c squared, okay, minus 20c plus negative 3c, that's the same thing again as negative 23c, so we're not changing the problem, plus 4. I want to break up that middle term this way. Now you could put the 3c here and the 20c here, negative 3c there and the negative 20c here. Order doesn't make a difference. The final answer will come out. Okay, so yeah, some of you might be saying, well, why don't you put the 3 and the 20? You certainly can. So don't get too caught up on that. So now we're going to take this and we're going to do what? Well, we're going to do some group factoring. Okay, so here is the problem with our negative 20c and negative 3c, and we're going to break this up into two groups, mentally speaking, okay? The first two here and the last two here, and we're going to factor out the GCF of each, okay? Now, I know a lot of you out there are like, oh, this is a lot of work. It's not that difficult once you practice this, and oftentimes this is easier than the guess and check method. Okay, so here, what do I have? Well, I can factor out a 5c, and every time you're not quite sure, you can just multiply this back in, right? 5c times 3c, 15c squared, and then 5c times negative 4 will give me back to a negative 20c. Okay, so factor out that GCF right here, and then over here, you might be saying, well, there's no GCF, but here's what I want you to pay attention to. You want to try to come up with the same binomial. Here I have 3c minus 4, and this is pretty close to 3c minus 4, but the signs are off. So what you want to do in this case is you want to factor out a negative 1. Okay, so this is always a kind of common thing that you can do. So if I factor out a negative 1, all right, so if I multiply this negative 1, I'm going to back into this here, this binomial, negative 1 times 3c, will get me back to negative 3c, and negative 1 times negative 4 will get me back to positive 4. If I factor this out, guess what happens? Well, I have the same binomial right there, okay? So if you were able to, let me go ahead and come up here. If you were able to find a pair of factors that adds up to that middle term, this thing will factor, okay? All right, so now we can actually factor out this 3c minus 4. We can factor this out. I know it's kind of confusing, but when we factor this out, we're left with 3c minus 4, and what remains is 5c minus 1. That's what goes in this other binomial. So we have 5c minus 1 times 3c minus 4. In other words, I could take kind of the distributive property and factor this out, and I'm left with this. Okay, because if 3c minus 4 multiplied by this and 3c minus 4 times that would be this right here. Now, I know a lot of you are, probably exacerbated, like, oh my goodness, this is crazy. Listen, I've been teaching this stuff for decades, thousands and thousands of students I've taught, and I can tell you right now, those students that have difficulty with factoring, these more, involved quadratic trinomials will do better with this technique. Okay, instead of the guess and check method, because what's your alternative? Well, let's go back up here. Your alternative is to look at all your options right here. Okay, I have to put factors of 4, 1 and 4, 4 and 1. And you could do this, and this is a good technique as well, but oftentimes a lot of students kind of struggle with this, where if they're just kind of given a procedure, they can do this every single time. So it's up to you as long as you know how to factor, but I'm going to strongly suggest that however you factor, you should know this technique. Okay, so let's go ahead and revisit where we're at in the problem. Again, I did tell you this was going to be an interesting problem. So we took that numerator, 15c squared minus 23c plus 4, and we were able to factor it into these two binomials, 5c minus 1 times 3c minus 4. Now we're going to factor that denominator, and hopefully we're going to find some of these factors amongst the factors of this quadratic trinomial. So let's go ahead and do that now. We're going to use the same technique. And here, this is going to be a lot easier because the numbers are easier. So this is positive 10 times negative 1. That gives me a negative 10. So we're looking for factors of negative 10 that add up to 3. So here are the factors of negative 10. And, this is pretty easy. You're like, oh, negative 2 times 5 is negative 10, but when you add these up, that's a positive 3. So these are the numbers I want to use. Okay, so negative 2 and 5, we're going to write our 3c in terms of negative 2 and 5. So let's go to do that right now. So instead of 10c squared plus 3c, we're going to write this as 10c squared plus 5c plus a negative 2c minus 1. Again, it doesn't make a difference what order you do this in. It will come out, the quantities will be initially different, but your final answer will be the same. Okay, so at this point, you want to go ahead and break these up in two groups, our first group and our second group, and factor out the GCF. So here I can factor out a 5c, and that's going to leave me with a 2c plus 1. And then here again, I'm going to factor out a negative 1, and that'll leave me with a 2c plus 1. And now I can factor out a 2c plus 1, and that leaves me with 5c minus 1 right here. Okay, so again, a lot of work involved. So our denominator trinomial turned out to was able to be factored into 5c minus 1 times 2c plus 1. Okay, so tons of work, and hopefully you can see that we have like factors there. So let's kind of zoom in so we can see this here. So we have 5c minus 1 and a 5c minus 1 in the numerator and 5c minus 1 in the denominator. These are like factors, so we can cross cancel them, and that leaves us with the following right there. 3c minus 4 over 2c plus 1, and there you go. Now, I know a lot of you out there are, have few expressions. Maybe some of you are like this: I hate algebra. This is why, I'm definitely not going to go into anything technical. Listen, don't, stay in this state. Even if you don't like algebra, that's fine. I'm not going to try to convince you. But if you have to pass your algebra class, you have to just try to change your attitude. Like, okay, I'm just going to learn this step by step. Okay, because my objective here is to get you to, at a minimum, pass your algebra course, your math course, with a minimum, of like a B. All right. You might say, well, why don't you say C? Because you can do better than that. Now, are you always going to get A's on your test? No, everyone, even strong students have bad test days. But if you even if you don't like the subject, if you are willing to, pay attention, work hard, and just kind of, immerse yourself in it, you're definitely smart enough to pass with a minimum of a B. Okay, it's really up to you, right? But when I do these problems on, in my math courses and on YouTube, I'm really trying to show you the real deal in terms of the stuff that you're going to be facing in an algebra course. So, in terms of level of difficulty, I would say this problem, yeah, in like a typical Algebra 1 class might be like a 7 out of 10. Okay, so some of you are like, wow, there's problems that are more difficult. Yes, indeed. Okay, but it wasn't the simplest of problems because we did, whatever technique you used, factoring these quadratic trinomials, did take a decent amount of work. Okay, so hopefully this video helped you out. If that's the case, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.